Welcome back, everybody. We're going to continue with the 2022 Waec Ssce for the mathematics examination questions. The next one is number 11. If to the product of these matrices, this one has elements 2, minus 3, 1, 4, and this one with elements minus 6 and k is equal to another matrix with elements 3 and minus 26. Find the value of k. That's simple. We just multiply the two matrices on the left hand side. And how do we do that? 2 times minus 6, that will be minus 12, minus 3 times k, that's minus 3k. And we go again, multiply this row by this column. 1 times minus 6 is minus 6, 4 times k, that will be plus 4k. And now that result will be equal to the matrix on the left hand side, which has elements 3 and minus 26. So that simply means the two matrices are equal, which also means that their corresponding elements are equal. And this element will also be equal to this element. So we can choose either of the two comparisons to get to obtain the value of k. That means I'm choosing this one, minus 12 minus 3k equals 3. And this simply means minus 12 minus 3 equals plus 3k. And that means minus 15 equals 3k. When we divide both sides by 3, we get k equals minus 5. And that's the answer simply. We go straight to the next, which is number 13. Number 13 isn't clear in this copy I have. I think I'll just go to number 14. Number 14, find the coefficient of x squared in the binomial expansion of x plus 2 over x squared raised to power 5. This simply means we should find what the coefficient of x squared will be when we expand this. So let's go. That simply means 5 combination 0 times x raised to power 5. We know that in this expansion, the power of x decreases across the expansion, while the power of 2 over x squared increases across the expansion. So the power of x starts from 5 and decreases until it gets to 0, while that of 2 over x squared starts from 0 and increases until it gets to 5. So that means here we have 5 combination 0 times x squared over 2 times x raised to power 5 or times 2 over x squared raised to power 0, plus the next term will be 5 combination 1 times x raised to power 4, that's decreased by 1, times 2 over x squared raised to power 1. This has also increased by 1, plus the next term is 5 combination 2 times x raised to power 3 times 2 over x squared raised to power 2, plus I don't need to write the remaining terms because I can already see that this is a term that contains x squared and I only need the coefficient of that term. So that's what I'm just going to simplify. The x squared term is all I need. Now let me just paste it here. The x squared term, this is the x squared term, and it's equal to 5 combination 1 is 5 times x raised to power 4. 5 times x raised to power 4 times 2 over x squared raised to power 1 is the same as 2 over x squared. And we can see that x squared, x raised to power 4 divided by x squared is x squared. So that simply means 5 times x squared times 2, which is 10x squared. So that means the coefficient of x squared in the expansion is 10. And we go straight to the next, which is number 15. Number 15 says, given that P equals the set P has element x such that x is a multiple of 5. Let me just read through. Given that the set P has element x such that x is a multiple of 5, and the set Q has element x such that x is a multiple of 3, and the set R has element x such that x is an odd number. Find, okay, all of those sets P, Q, and R are subsets of U. P has element x such that x is a multiple of 5. Q has element x such that x is a multiple of 3, and R has element x such that x is an odd number. Are all subsets of the set U. And what's the set U? Let me write the set U. Set U, which has element x such that 20 is less than or equal to x, and x is less than or equal to 35. That simply means the elements of a set U are numbers from, let me write that well, are numbers from 20 to 35. So what are the elements of P? The elements of P will be multiples of 5. The multiples of 5 from 20 to 35 are 20, 25, 30, and 35. Now, what are the elements of a set Q? The elements of a set Q are multiples of 3. So what are the multiples of 3 from 20 to 35? That's 21, 24, 27, 30, and 33. Now, what are the elements of a set R? Those are odd numbers, the odd numbers from 20 to 25, and those are 21, 23, 25, 27, 29, 31, 33, and 35. Those are the odd numbers from 20 to 35. Now the question is, find the element of the set P union Q intersection R. That will be equal to, first of all, I want to find the set P union Q. That's a combination of a set P and Q. So how do we do that? We just write all of the elements of a set P, which are 20, 25, 30, and 35. Let's put that here. These are the elements of a set P. Now, what do we do next? We now write the elements of a set Q, which are not already in P. That's a very good trick for writing the elements of a combination of two sets. So, what are the elements that are in Q that are not in P? Those are 21. 21 is not in P. 24 is not in P. 27 is not in P. 27 is not in P. 30 is already in P. And 33 is not in P. So I write that. 30 is already in P, but 33 is not in P. So I just write 33. So this is P union Q. Now I put that side by side with R to now see what's common to R and to see what's common to the set R and the set P union Q. So let me just paste that here. Yeah, this is the set R. So now I want to see what elements are common to P and R. So these are the elements. 20 is in R, is in P union Q, but it's not in R. 25 is in P union Q, it's also in R. 30 is in P union Q, but it's not in R. 35 is in P union Q, and it's also in R. Now 21 is in P union Q, and it's also in R. 24 is in P union Q, but it's not in R. 27 is in P union Q, and it's also in R. 33 is in P union Q, and it's also in R. So those are the elements of P union Q intersection R. 25, 35, 21, 27, and 33. So therefore, P union Q intersection R has elements 25. Let's write them out. 25, 35. We know arrangement doesn't matter. 21, yes, 21, 27, 27, and 33, and 33. So those are the elements of P union Q intersection R. Let's see if that matches any of the options. 25. Okay, what I see here is 21, 25, that's correct. 27, that's correct. 33, that's correct. And 35, beautiful. That's it. That's very, very correct. And the correct option actually is B. Even though their own arrangement is different, you still have the same elements. Now, the next one is number 16. A particle moving with a velocity of 5 meters per second. That simply means U is 5 meters per second. Accelerates at 2 meters per second squared. A equals 2 meters per second squared. Find the distance it covers after 4 seconds. Time is 4 seconds. What distance did it cover after 4 seconds? You can simply use the formula S equals ut plus half at squared. And that simply means 5 times 4 plus 1 over 2 times acceleration is 2 times t squared, and that's 4 squared, which simply means 20 plus half of 2 is 1, and then 1 times 4 squared is 16, and the answer is 36 meters. That's very, very simple. That's on option C. And we go straight to the next. What's the next one? That's number 17. Number 17 says if un is equal to kn squared plus pn, and u1 is minus 1 while u5 is 15, find the values of k and p. I think this should be simple. Let's go. U1 is minus 1. That simply means k times u1 is actually equal to k times 1 squared plus p times 1, which means k plus p. And we know that the same u1 is minus 1. K times 1 squared, let me write it this way. I think it would be better to write it this way. U1 is k times 1 squared plus p times 1, and it's given as minus 1. So that simply means k plus p equals minus 1. U5 equals 15. That simply means U5 equals k times 5 squared plus p times 5, and that's given as 15. So that simply means 25k plus 5p equals 15. Yeah, we can divide through by 5 to have 5k plus p equals 3. Let me call this equation 1 and call this equation 2. Now I want to solve the two equations simultaneously. K plus p equals minus 1, and equation 2, 5k plus p equals 3. What do? I can just subtract equation 2 from 1. K minus 5k is minus 4k, and p minus p is 0, equals minus 1 minus 3 is minus 4. And when we divide both sides by minus 4, we get k equals 1. So we can put k in equation 1, which means 1k plus p equals minus 1. That's equation 1. And that simply means 1 plus p equals minus 1, which simply means p equals minus 1 minus 1. And that means p equals minus 2. So k equals, what's k? K equals 1 and p equals minus 2. And the correct option is C. K equals 1 and p equals minus 2. And now let's go. Okay, what's the next one? The next one is number 18, which says, in how many ways can 6 persons be paired? In how many ways can 6 persons be paired? That means, in how many ways can we make 2 out of 6. That's what it means. That's just 6 combination 2. And that, 6 combination 2. Do we need any long working for that? 6 combination 2. And that's 15. Yeah, that's 15 simply. Now the next one is 19. And the correct option, by the way, to number 18 is C. Now number 19 says solve 3 raised to the power 2x minus 2 minus. This is a simple one. Why isn't this looking quite clear? Minus 2 into bracket minus 2 into bracket 3 raised to the power x minus 2 plus 3 equals 0. This is looking like this minus 2 is minus 28 or something. The question is not quite clear. But the ones I'm skipping, I'll come back to them maybe in the second part. I'll get a copy of a question that's clearer for the questions I can't read clearly here. So let me just go to number 20. That's also not clear. I think I should just get a copy that is clearer. Let's stop here for now. I'll be back in a sec. Don't go away. And please subscribe to the channel and hit the notification button so you always get notified when a new video is uploaded. Thank you very much, and I'll see you in a bit. Bye-bye.